So this is the video for the chapter 12.1 lab. Hopefully by now you have read through the lab and you have that supplemental worksheet. It's in your packet, but just have it to reference. But if not, go ahead and pause the video, go back and read the instructions and do that now. And then I'm going to go ahead and get started. So this is the first page of the 12.1 lab. And so by now you've already looked over and decided which cereal you think is the most nutritious. And really there's going to be a lot of different answers for this as in terms of what you feel is most nutritious. But what I did want to do is see if this kind of persuades you, because right now all you can see, actually before I do that, let's look at what we have here. We have 3 cereals. We don't know what they are. But you can notice some things, and depending on your version of nutritious, you could say, wow, well, cereal 1 has, I don't know why it's highlighting up there. No, just ignore that. I'll use a pen. Cereal 1 has a lot of sugar. Or you could say, what else could we look at to be unhealthy? Calories. Well, they're all about the same, but here we have calories from fat. That's a high number. Or, higher than the other 3, but maybe that's not as big of a deal to you. Maybe you like this guy because it's low fat. It's the lowest fat of the 3. However, the sodium is higher. In fact, this guy has the highest sodium of all. So anyways, there's different reasons why you think something is healthy. And so I'm going to tell you the names of the cereal and see if that persuades you one way or another. So this first cereal is Cocoa Puffs. The second cereal is Corn Flakes. And the third cereal is Cheerios. And so right now I'm guessing nobody chose the first one. And you can see, just by the names of it, you're like, yeah, Cocoa Puffs is not going to be the one that I would consider the most nutritious. Usually it's kind of a tie in my classes between Corn Flakes and Cheerios. So like I said, there's a number of different reasons why you might have chosen one over the other, but it's just a good place to start. We're going to be talking about different graphs as they relate to these cereals. So here we have, and this was, I'm not going to fill in one because that's your opinion, but that was what I was just talking about. Okay, so here we have consumer reports, and we have this dot plot. We've talked about dot plots. That was back in chapter 2. But one thing I really want to focus on different, or in addition to what we talked about before, is, let's see, I don't know if you guys can see that. It's annoying. Okay, what does each dot represent? I want to focus on that more in this chapter than we have in previous chapters. But what we have here is we have a whole bunch of cereals, and it has their rating. So this guy had a rating of a 94. We had 2 have a rating of a 74. We had some low cereal over here. Looks like it had like 18 or 17 or something. And so each dot represents one cereal. We can see what their rating is on the table, but the dot themselves represents a cereal. So for this particular distribution, the average rating, I would say anywhere in this middle part here would be a good answer. So if you had any number in there, 40 to 44, or you just put a range like I'm doing here, I think that's great. We just went somewhere in the middle. If you were a little lower, because there's more dots, somewhere around here, I would say would be okay as well. But just make sure your answers aren't in the 20s or in the 70s or something far. Okay, and then what is the range for the ratings? We've talked about this, again, a review from a previous chapter, but to find the range, we want to subtract the maximum minus the minimum. And you might not have exactly the same answer as I do. It kind of depends on how you estimated this. But I said the max looks like it's 94. The minimum looks like it's about 18. So, oh, I don't want to do this on the top of my head. So I'm pulling out my calculator and I'm getting 76 as my range. How would you describe the variability? I would say, most, I wouldn't say 94 to 18 to 94 really describes the whole thing because we have this huge gap over here. So for the variability, I would say something like most are between what it looks like about 20 to 60. Okay, so what we can't tell, tells us right here, what we can't tell is how the different ingredients relate to the rating. So this dot plot right here, this is very one-dimensional. We don't even have any sort of scale going on over here on the up and down axis. I mean, other than counting how many dots there are. We don't know what's going on. There's no other information. This is strictly ratings, and each dot is one serial. So these techniques that we used in previous chapters aren't going to be relevant to the techniques we need in this current chapter of scatterplots. And so what we're going to do is we're going to look at the relationship between two quantitative variables. We need quantitative variables because we need numbers. We need to be able to explain what's happening on this chart using numbers, not words. Because if I gave a survey to the class and I said, are you super bored right now? Of course you're not bored right now as in during this lecture, but I just mean in life in general. I'm super bored right now. So you would either say yes, or you would say no, and we would have all the responses, and that's really boring. It's just two straight lines. What we want is to get scatter plots. We want to have a scatter of these designs or of the data and explain the patterns going on. And so what we have, it says supplement 3.1a. What that is on page, it's actually 12.1. It's page 127. I printed this out separately just so it's easier to go back and forth as we talk about this, but this is just page 127. So if you haven't looked at this chart yet, make sure you have access to it. This is not a separate piece of paper. This is just a couple pages forward from where you are right now. So this right here is talking about page 127. Okay, so going back to page 127, we have two things going on. We have, so in algebra, I would say this is the x-axis, and I would say this is the y-axis. In statistics, we are going to use our same variables that we talked about before, which would be explanatory. Let's see how I can write this. Explanatory is going to be on the x. And then I'm going to try to turn my tablet sideways, see if this works. We have the response. There we go. The response is the y variable. So the response is going to go up and down. And so for this first question, it says, I'm reading from problem 3, but I want to look at the chart while I'm doing it. It says, what are the explanatory and response variables for the sodium ratings scatter plot? So here I have the sodium scatter plot. It's the fourth one. The explanatory is along the x, so that would be the sodium. And the response is along the y, so that would be the rating. So going back to question 3, we have the explanatory, we said was the sodium. And then the response is the ratings. Now it gives you a clue right here. It tells you the two things you have to choose from. You just have to say which one is the x and which one is the y. And if you remember ordered pairs from algebra, look at that. It fits right there. Sodium, ratings, x, y, explanatory, response. Okay, so the formula for how they calculate this is not made public. So we don't actually have a formula, but we can talk about different clues that these scatter plots have. And so what we want to do is first, we're going to, I'm going to read through this and then we'll compare this to the chart. So it says 2 new cereals are being rated by Consumer Reports. Cereal A has 1.5 grams of sugar and cereal B has 2.5 grams of protein. Predict how the Consumer Reports ratings for the 2 cereals, predict what that is based off the data in the scatter plots. So here we have the scatter plots. And so I'm just going to write it off to the side so that I don't have to keep looking back. But we said the instructions that I just read, this is not connected to the picture. I'm just taking notes real quick. It said A had 1.5 grams of sugar and B has 2.5 grams of protein. So we are going to try to guess what that rating is based off of these tables. So first, the sugar, and the sugar is the second chart over here on the top row, and it says A has 10.5 grams of sugar. And so 10.5, well, let's see, I have 10 and then I have 11. So 10.5 is not, I'm going to zoom this in because my dots are going to get big. 10.5 is not exactly on the graph, but 10.5 would be in this area right here in between 10 and 11. So it seems like there could be a dot anywhere in that, on that little green line right there. And it would be reasonable. It would follow the pattern. It would follow the flow of this graph. So I would say somewhere between 20 and 40 would be a good answer. So I'm going to jump back and write that down before I forget. So for cereal A, I would say between 20 and 40. This would be the rating. So I don't really need units on there, but the rating would be between 20 and 40. And then how did I use the scatter plot? Well, you could see what I drew on the picture. So when it says tell, I'm just going to say look at picture because you can see what I drew on there to kind of explain what that is. Okay, so for B, it says, I wrote it down right here. It says 2.5 grams of protein. So I'm going to go to the protein picture and same idea, 2.5. Now this time it's a little easier to see on the graph. That's 2.5, on the scale. But the graph itself, again, it's blank. So somewhere in there. Now I don't want to go all the way here because, I'll erase this, there's no dots on this picture to support something that high. And there's no dots on this picture to support something that low. So I don't want to have just random dots anywhere, but I want to kind of draw this green line so that it mimics what's happening on either side. So if I had a dot anywhere on this green line, it would follow the overall pattern of this picture. So it seems like maybe a low of 25 and a high of maybe 70 or so, somewhere around there. Again, they don't have to be perfectly exact answers, but as long as your answers are in the ballpark, that means you know what's going on. So between 25 and 70. All right, one is more accurate. One prediction, looking at number 5, is more accurate. Which one do you think is more accurate and why? So going back to this picture, now you can see why I said I'd have this picture handy. It seems like, in my opinion, that the sugar graph is more accurate because it's a smaller range. I said between 20 and 40. They're kind of more clustered together. Whereas the protein picture, we gave a pretty broad estimate. 25 to 70 was pretty spread apart. So I would say, oops, where's my thing? Cereal A is more accurate. Oh, that's terrible. accurate. Because the ratings are closer together. Meaning our guess, I'm just going to write just to be clear, our 20 to 40 rating, those guesses we came up with for example 4, the ratings are closer together. If I said, oh, it's not even 2 words. All right, if I said pick a number between 20 and 40, you have a better chance of guessing my number than if I said pick a number between 25 and 70. So the fact that that range is just a little tighter for cereal A means that that prediction is going to be more accurate. Okay, so using that picture that we talked about, go ahead and try 6 through 8. And I'm going to just pause the video first, or I'm not, you are going to pause the video for a second. Go ahead and try 6 through 8 and then unpause the video when you're done to check your answers. All right, and we are back. So looking at 6 through 8, it says Captain Crunch had the lowest Consumer Reports rating of the 77 cereals in the data set. How much fat is in the serving of Captain Crunch? So we are back at our tables. And it said Captain Crunch was the lowest. So if I look at my fat, this is the first graph in the picture here. If I look at my fat, I said the lowest one is that guy right there. That's the dot, that's the cereal that is the lowest, like physically the lowest, closest to the bottom on the picture. And that dot falls on the category of 2 grams. So that is how we know that the Captain Crunch must have 2 grams of fat. It says product 19, which is actually a real cereal. I Googled that one semester because I had never heard of that, but it is a cereal. It says product 19 has the most sodium. And so going on the sodium, sodium is measured left to right. So the most sodium is going to be on the most right. And so this dot right here is the farthest right on this picture. And it says, what would that rating be? And so I can see it's above 40, but it's nowhere near 50. So it looks like about 42 would be a good estimate for that rating. So 42, and we can even put ish, about 42. Again, there's no units on the ratings because that's just what the score is. So we can just leave it as 42. All right, finally, it says all bran extra fiber has the highest rating. How much sugar, fat, and sodium are in this all bran extra fiber? So looking here, has the highest rating. I'm going to clear off some of these drawings just so we can see all the pictures a little more clearly. So how much, start with sugar. Which sugar has the highest rating? Now ratings again is on all of these pictures is on the Y. So the highest rating is the tallest. So here is the sugar. I can see, or that's the highest rating. So I can see that it has 0 sugar. On the fat picture, that's the first one, highest rating. I can see corresponds with 0 grams of fat. And then highest rating for sodium. Now this one's not on 0, but the highest, straight up, the dot that's the highest up is right here. And that looks like maybe about 140 grams of sodium. So going back to this last problem, it has 0 grams of sugar. It has 0 grams of fat. And anything that you put that is about 140 grams of sodium is good. If you put 135, leave it. If you put 12, you're wrong. So anywhere that's around 140 is a good answer. Okay, so now we're going to start looking at patterns and relationships in these scatter plots. And so we want to focus on how patterns in the data help us identify ingredients that are good predictors. And so it says there's 4 cereals that have 3 grams of fat in a serving. Estimate the ratings for these 4 cereals. So 3 grams of fat. Going back to my table, where is my fat? The first one. There are 4 cereals that have 3 grams of fat. So we can see them, all 4 cereals. Is there 5? Am I losing my mind here? No, there's 5. Okay. There's 5 cereals right here on the list. Estimate their ratings. So it looks like the bottom one's easy. That's 20. Looks like we have a 40 in there. And so maybe we could say 38 and 36, somewhere in the ballpark of that. And then finally, what is that? Maybe 46 up there. So it looks like I wrote 96. I'll write it clear here. It looks like, we'll say my favorite word, about 20, what did I say? 36, 38, 40, and maybe 46. You know, anywhere near that, we're estimating where those dots are. And it says, explain, or why do you think the ratings are not all the same? Well, the ratings are not based on fat alone. Ratings are based off of of all the ingredients, or all those four categories. So they're based on more than just fat. So in the pictures we have, there's actually 4 categories that they're based on. And so the ratings aren't going to be the same for everything that has 3 grams of fat, because the one with 3 grams of fat could have higher sodium or lower sodium, or more sugar or less sugar, or something like that. Okay, so we want to imagine that a cereal has 0 grams of fat and a rating of 60. The cereal company decided to increase the amount of fat to 3 grams of sugar. What do you think is to 3 grams per serving. Okay, I can read. Do you think the rating will most likely increase, decrease, or stay the same? So let's look at our picture. It was at, I colored over this one. It was at 0. It's one of these dots on this line. And they decided to, whatever they did to the formula, they actually gave it 3 grams of fat now. So the X is moving that way. What's going to happen to the Y? Well, looking at this trend, it seems like the dots are kind of going in a downhill pattern. It's not a straight line. Obviously, you can see there's dots above the line, there's dots below the line, but the overall pattern is, and this also kind of plays to your logic about what you know about food, the more fat, people aren't going to like it as much. There's all this stuff on here. Okay, so it's going to lower the rating. Probably. Now look over here. We have some, this dot, this dot, this dot, this dot. They all have a rating of 40. So I can't say, I guarantee the dots are going to go down, but I can say probably. It's like about or ish, my favorite. So I'll say it will, this is most likely in the problem anyways, probably decrease. Now, if you said it would probably remain the same, I could see why you think that. But just looking, kind of stepping back and looking at the overall pattern, it sounds like it's decreasing overall. Do you think it would be impossible to predict? And how does the pattern? So we talked about all that on the picture. The pattern kind of gives this downward slope looking thing that kind of describes the picture. Again, kind of. All right. So we are almost done, and we've talked about a lot. So what I want you to do is pause the video one last time and go ahead and look over 11 through 14 and see if there's anything else you can add to what you already wrote on your picture, or not your picture, on your work. Okay. Pause the video. Okay, and we are back looking at 11. So it says, which ingredients have a positive impact on the ratings and how can you tell? Let's look at the patterns. So going back to the pictures, I shouldn't have erased this, but we said this one had kind of a negative impact. So what's going on in the other pictures? Well, sugars seem to also have a negative impact. They kind of follow that downward pattern. Protein seems to be getting higher as you go over time. And then sodium, it's not as clear, but I would say it's definitely going down. It's definitely not going up. You know, I could see you arguing that it stays the same because it's not really going down by very much, but it's definitely not going up. And this question was, which one has a positive impact? So I would say that protein is the only one. Protein has a positive impact because the overall picture goes up, meaning the line that I drew is going up, has a positive slope. Which ingredients have a negative impact? And so definitely fat and sugars are going down. The sodium, maybe, but definitely fat and sugar. Again, I kind of made the sodium line go down, but even if you drew kind of a straight line, it kind of describes, and you know, these outliers up here, they're kind of messing with my pattern too. So I would say fat and sugars, we could definitely say that about. And if you added sodium, I could see why. So fat and sugars. And again, that's just what you would think anyways, even if you knew nothing about this class. If you just turn to like, well, you don't have a neighbor, but like, I don't know, your mom, your brother, whoever, your dog, whoever's sitting next to you right now, and you're like, what's bad about food? They would say fats and sugars. What's good about food? They would say protein. So this kind of follows what we know about food anyways, but now we have the pictures to prove it. Okay, which one seems to have the strongest impact on the rating? Now it doesn't say, strongest doesn't have to be good. It could have the strongest positive or the strongest negative impact on the ratings. I don't know why my children are talking in the background. They should be outside. Sorry about that. Okay, so looking at the pictures, which basically what I'm saying is, which line makes the most sense with the dots? Which line is closest to the most dots? And so that's the one that's going to have the strongest impact because that's going to be the one we're most confident about. And so looking at the fat, I see dots above and below, but they're kind of far away. Looking at the protein, you know, they have a lot of dots that are kind of far away from the line. But looking at the sugars, they kind of all fit pretty closely to the line. I could do that same thing on these pictures instead of circling dots. If I wanted to draw a line and have most of my dots inside, that one's kind of wonky, but look at what's happening on the sugar. The blue to blue, that distance is the closest. This fat, it's kind of far apart. This protein, it's definitely far apart. Those blues are far apart from each other. Who knows what's going on with the sodium? But that sugar, that's a pretty tight picture. The blue, you know, the vast majority of the dots are between the blue lines, and the blue lines are pretty close together. So sugar is going to have the strongest impact on the rating because it has, sugar, yeah, that's fine. It has the least variability. In other words, the dots are closer together on that one than any of the other pictures. That's what I mean by variability. The dots are closer together. Okay, so for this last one, we have we're talking about fiber. So we have a new chart, and we want to see which chart here, think about how much fiber is in cereal. There's 3 scatter plots from 10 imaginary cereals. Which one looks similar to what you would see in actual data? So 2 of these are completely made up, and one of them is still made up, but at least it follows a more logical pattern. So we want to kind of look at what's going on, and it gives us a little hint. Think about whether fiber is healthy or not. Okay, so fiber is like protein. It's one of those things that is good for you. And so in theory, if people think it's good for you, then it's going to have a higher rating. So if it has, the more fiber, the higher the rating is going to be. So on picture 1, the more the fiber goes up, the more the rating goes up. On picture 2, the more the fiber goes up, the more the rating goes up. On picture 3, the more fiber you have, the lower the rating gets. So right away, we can throw out picture 3 because this picture is saying fiber is bad. So this is saying, the more fiber you are adding to a product, the lower the rating is going to be. So that's why we're throwing that one away. Now, looking at these last 2 that we have left, fiber 1 and fiber 2, which one is more similar to what you would see in actual data? So thinking back to those 4 pictures that we've spent most of our time looking at, did those 4 pictures have little dots all perfectly in a straight line, just like rating picture 1 does? Or did those pictures that we have more all over the place kind of numbers? And so this one in the middle is going to be most accurate. What does the question say? It says, which one might be similar to what you would see in actual data? This one in the middle is going to win because there's, I guess we see variety in real life data is the best way to explain it. We see variety in real life data. Data does not fall, real life is messy, real life is scattered, and that's what we're talking about in this. It can have a pattern to it, but it's still scattered. Real life does not say boop, 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 everything is perfect, everything is in a straight line. So this is, I guess you could say, too perfect. What we're going to describe, so this picture, fiber 1, is more like a mathematical model. It's something you would use to predict data. But this second one that I circled, that's more closer, listen to me. That's more closely related to real life because it's a little messier, it's a little more scattered. Okay, so just as a review, this is going to be very important for what we're talking about in the lectures for chapter 12. So you need to know which one, everything, basically you need to know everything in bold. So we want to have explanatory and response variables, making sure you know explanatory is the X and response is the Y. And we're going to be talking a lot about positive and negative associations. And we're going to be talking a lot about the strength. So the positive and negatives you're going to see in the 12.1 lecture. And then the strength is going to pop up again in the 12.3 lecture. And we will have another lab that talks more about both of those things. All right, so I hope you enjoyed the lab, and I will see you next time.